In this class, we will discuss about curve fitting, which is a topic in numerical analysis. When analytical methods are difficult to solve some problems such as finding the roots of x cube minus 9x plus 1 equal to 0, there numerical methods comes into the scenario. The difference between analytical methods and numerical methods is the exactness of the solution. Analytical methods provides exact solution, but numerical methods provides a solution with some error. So, when we are applying numerical methods, we need to focus on the error in the solution. Let us come to our topic, curve fitting. Suppose we have a function y equal to 2x plus 1. Then for any x we can evaluate y, right? Means for x equal to 1, y equal to 3. For x equal to 2, y equal to 5, and so on. But what if we have a data instead of function like this, and if we want to find the value of y at x equal to 6, we cannot evaluate y by seeing this table, but if we have a function which will fit to the data, then we will evaluate y for any x. That is what curve fitting does. I mean to say, the objective of curve fitting is to theoretically describe experimental data with a model. Model means that could be function or equation, and to find the parameters associated with this model. To do curve fitting, different methods are available such as graphical method, method of group averages, the least squares method. As least squares method is most systematic method compared to other methods, and as it can be easily implemented on a digital computer, we will approach least squares method to do curve fitting. In this class, I will explain two types of curves. One is straight line or first degree polynomial, second one is parabola or second degree polynomial. Before going further, I will explain briefly about the minimization of a function of two variables. Suppose we have a function f of a comma b, and we want to find where this function has a minimum. First step is we need to find first derivatives with respect to a and with respect to b. This is the step 1. As a step 2, we just convert these two as equations, means we take dou f by dou a equal to 0 and dou f by dou b equal to 0. Now, we can solve these two equations for the values of a and b. Those points are called critical points. Let one of the critical point is a naught comma b naught. Next, as a step 4, we have to calculate the second derivatives like r equal to dou square f by dou a square s equal to dou square f by dou b square and t equal to dou square f by dou a dou b. And as a step 5, we need to calculate rs minus t square. Now, we have two things in our hand, one is r, another one is rs minus t square. Now, we have to check whether rs minus t square at a naught comma b naught is positive and r at same the point means a naught b naught is positive. If these two happens, then we can declare the function f of a comma b has minimum at A naught comma B naught. I am ignoring the other cases maximum and saddle points. With these things in our mind, we can go for the fitting of straight line to the data and fitting of parabola to the data. This is the summary of first topic. In our second topic, I will explain how to get the normal equations, means how to fit a straight line or parabola to the data by using normal equations. As a second topic, we go for normal equations which are useful to fit a straight line or parabola to the data. Assume we have m data points. Our task is fit a straight line to this data. The general form of the straight line is a plus bx. So, what we need to do? We need to find the values of a and b, but how to get the values of a and b, we will come to that point. But I already told you, when we are applying numerical methods, there may be some error in the solution. So, here the y1 and a plus bx1 both are values corresponding to x1, and y2 a plus bx2 are the values corresponding to x2, and so on. Ym a plus bxm are the values corresponding to xm. Here y1 is called observed value, a plus bx1 is called expected value, and also here also same thing, y2 is the observed value, a plus bx2 is the expected value, and so on. Ym is the observed value and a plus bxm is the expected value. The difference between the observed value and expected value is called the error. So, these are the errors. These are the errors when we fit a straight line to the data. As I already mentioned, we need to focus on the error in the solution when we are applying numerical method. So, we need to reduce the error as much as possible. So, this is the part of least squares method in curve fitting. Least square methods provides us a function which is to be minimized, that is y1 minus of a plus bx1 whole square plus y2 minus of a plus bx2 whole square plus so on ym minus of a plus bxm whole square. This is nothing but the sum of squares of the error. Our task is getting the values of a and b by minimizing this error. So, here y1 x1 y2 x2 ym x are all known values. So, only unknown values are a and b. So, you can say this is a function of a comma b. I already explained how to get the minimum of a function. So, just we follow the same procedure. As a step 1, we need to differentiate with respect to a, and that value is nothing but 2 into y1 minus of a plus bx1 into minus 1, 2 into y2 minus of a plus bx2 into minus 1 plus so on 2 into ym minus of a plus b xm into minus 1. And also we need to find another first derivative with respect to b also. The answer will be 2 into y1 minus of a plus bx1 into minus b plus 2 into y2 minus of a plus bx2 into minus b plus so on 2 into ym minus of a plus b xm into minus b. As a step 2, we need to convert these two as equations, means by equating them to 0. So, dou f by dou a equal to 0 implies you can straight away write it as y1 minus of a plus bx1 plus y2 minus of a plus bx2 so on ym minus of a plus bxm equal to 0. Actually, I had taken over minus 2 as a common point and simply I took only this one. We can write this as summation of yi I equal to 1 to m, because we have considered m data points, and a is 1a, 2a and ma, because same thing we have m data points. So, we can write it as ma minus b into summation of xi I equal to 1 to m equal to 0. That means this is nothing but ma plus b into summation xi I equal to 1 to m is equal to summation yi I equal to 1 to m. This is one equation. We got this by taking dou f by dou a equal to 0, and we will get another one by taking dou f by dou b equal to 0. So, here dou f by dou b is nothing but this one. So, here we can write it as y1 minus of a plus bx1 into b, sorry, this is minus 1 minus x1, this is minus x2, this is minus xm. So, this is nothing but into x1 plus y2 minus of a plus bx2 into x2 plus so on ym minus of a plus b xm into xm equal to 0. This can be written as summation of xi yi I equal to 1 to m minus a times summation I equal to 1 to m xi minus b times summation I equal to 1 to m xi square equal to 0. So, implies you can write it as a into summation I equal to 1 to m xi plus b into summation I equal to 1 to m xi square equal to summation I equal to 1 to m xi yi. So, we have got two equations, those are m into a plus b into summation xi I equal to 1 to m equal to summation yi I equal to 1 to m. Another equation is a into summation I equal to 1 to m xi plus b into summation I equal to 1 to m xi square equal to summation I equal to 1 to m xi yi. So, this we got these two equations by taking dou f by dou a equal to 0 and dou f by dou b equal to 0, means step 2 is completed. As a step 3, we need to solve these two equations to get critical points, but here if we observe carefully, these two are two equations, two linear equations in a and b. So, if we solve these two equations, we will get only one solution, because we have two unknowns and we have two equations. So, we will get only one solution. Let it be a naught comma b naught. As this is the only one critical point obviously this will be the minimum, means that function f of a comma b has minimum at this point. So, substitute these two values in the required equation. Our required equation is y equal to a plus bx. So, substitute a naught instead of a and b naught instead of b, means y equal to a naught plus b naught x. This will be the required straight line which is the best fit to the given data. So, what we did till now, we have used the concept of minimization of a function of two variables, and we got two equations. After solving those two equations, we will get one, means we got one critical point, that is a naught b naught, and substitute in the general equation of straight line, we will get the required straight line. So, when we are fitting a data, we need not do all these things, just we need to remember only these two equations which are called normal equations, which are useful to fit a straight line to the given data. And do remember, here m is the number of data points. So, if you follow the same procedure, we can fit a parabola to the given data also, but only difference is the general form of parabola is y equal to a plus bx plus cx square, means here we need to find three unknowns, those are a, b, c. So, in order to get these the values of a, b, c, we need to follow the same procedure which we used in straight line, means dou a by dou a equal to 0, dou a by dou b equal to 0, and dou a by dou c equal to 0, like that, where f of a comma b comma c is nothing but y1 minus of a plus bx1 plus cx1 square, right, whole square, plus y2 minus of a plus bx2 plus cx2 square whole square, plus so on ym minus a plus bxm plus cxm square whole square. So, after finding dou a by dou a, dou a by dou b, and dou a by dou c and equate them to 0, we will get three equations, because here we have three equations, right. So, we will get three equations. They are m a plus b times summation I equal to 1 to m xi plus c into summation I equal to 1 to m xi square, which is equal to summation I equal to 1 to m yi. And second equation is a into summation I equal to 1 to m xi plus b times xi square plus c into c times summation I equal to 1 to m xi cube, which is equal to summation I equal to 1 to m xi y. But you will get another equation, that is summation a into summation I equal to 1 to m xi square plus b into summation I equal to 1 to m xi cube plus c into summation I equal to 1 to m xi cube xi power 4 summation I equal to 1 to m xi square yi. So, these are called normal equations in case of fitting a parabola to the data. So, if you want to fit a parabola to the data, we need to remember only these things, and after solving these three equations, we will get the required values of a, b, c, like a naught, b naught, c naught, and substitute here we will get the required equation a naught plus b naught x plus c naught x square. Here also same thing, we have three unknowns and we have three equations. So, upon solving these three equations, we will get only one critical point, that is a naught, b naught, c naught. So, if you follow the same procedure, we can fit any degree polynomial to the given data. But in this class, we are confining ourselves to only these two things, one is straight line, another one is parabola. In our first topic, we have discussed about the objective of curve fitting and the minimization of a function of two variables. Now, in the second topic, we have learnt how to derive normal equations to fit a straight line and to fit a parabola to the data. Now, in this session, we will see some examples related to straight line and parabola. If time permits, I will explain another two functions, power function and exponential function. So, as a first example, this is related to straight line. See the slide. This is the problem about how to fit a straight line of the form y equal to a plus bx to the data. So, we have x and y 0, 1, 2, 3 and y values are 2, 5, 8, 11. So, we are fitting a straight line to the data. So, we need to remember how the normal equations are. So, the general form of straight line is a plus bx and the normal equations related to straight line are m into a plus b times summation I equal to 1 to m x I equal to summation I equal to 1 to m y I. Second equation is a times summation I equal to 1 to m x I plus b times summation I equal to 1 to m x I square equal to summation I equal to 1 to m x I y I. So, here only 4 data values are given, means m equal to 4. Okay. So, x, y, what we need to know, m is okay. So, x I means that is the sum of all values of x, y I means the sum of all values of y. Still we need to evaluate the sum of x I square, right, means x square, and another one is x into y. This is the sum of the values of x y product. So, here x value is 0, y corresponding y value is 2 and this is 1, this is 5, this is 2, this is 8, this is 3, this is 11. Means here x square is 0 and here corresponding to x equal to 1, x square equal to 1, corresponding x equal to 2, x square equal to 4, corresponding to x equal to 3, x square is 9. And the product is nothing but 0 into 0 0, 1 into 5 equal to 5 and 2 into 8 equal to 16, 3 into 1 equal to 33. So, here all I told you m equal to 4 and sum of x I is nothing but 6, right, 1 plus 2 plus 3. So, means this is 6 and sum of y I, the values of y I is nothing but 7, 15, 26. So, this is 26. So, our first equation will be like this, 4a plus 6b equal to 26. So, I am erasing this one, and in the second equation we need to substitute sum of x I, sum of x I square, sum of x I y I. But here sum of x I square is nothing but 14 and sum of x y equal to 54. So, second equation can be written as 6a plus 26b equal to 54. So, I am erasing second equation also. So, on solving these two equations we can get the required values of a b. Here can multiply this one with 3 into 2 means first equation will become 12a plus 18b equal to 78, and second equation will become 12a plus 52b equal to 108. So, this is nothing but minus 34b equal to minus 52, 34. So, B equal to 14. Mistake. Okay, I had a mistake here. 6a plus 14b equal to 54. So, second equation will become as 28, means this is nothing but minus 10. So, b equal to 3. So, 4a plus 6b equal to 26, means 4a plus 18 equal to 26, means 4a equal to 8, means a equal to 2. So, a equal to 2 and b equal to 3. So, after substituting these two values in the general form of straight line, we will get the required straight line, which is the best fit to the data, is 2 plus 3x. In the similar manner, we can see another example which is related to fit a parabola to the data. This is the problem. Fit a parabola of the form y equal to a plus bx plus cx square to the data, this one. And here, when we want to fit a parabola to the data, we need three normal equations. Those are m a plus p times summation xi plus c into summation xi square equal to summation yi equal to 1 to m, and second equation is a into summation xi plus b into summation xi square plus c into summation xi cube equal to summation xi yi I equal to 1 to m, and third equation is this one, summation I equal to 1 to m xi square plus b into summation I equal to 1 to m xi cube plus c into summation I equal to 1 to m xi power 4 equal to summation xi square yi. So, here m equal to 4, because we have only 4 data values, minus 1, 0, 1, 2, and corresponding values are minus 2, 1, 2, 4. So, here we need to find summation xi, this is the usual thing, summation yi, but what we need extra is xi square, means x square, x y, x square, x cube, x power 4, x y, and x square y. So, here summation of xi equal to 2, summation of yi equal to 5, summation of xi square equal to 8, summation of xi cube equal to 8, summation of xi power 4 equal to 18, summation of xi y equal to 12, summation of xi square y equal to 16. Substitute all these values in these normal equations, we will get like this: 4a plus 2b plus 6c equal to 5, 2a plus 6b plus 8c equal to 12, 6a plus 8b plus 18c equal to 16. On solving these three equations, we will get a as 0.55, b as 2.15, c as minus 0.25. On substituting these values in the general form of parabola, that is a plus bx plus cx square, we can get the required curve as y equal to 0.55 plus 2.15 x minus 0.25 x square. So, by using these normal equations we can solve n number of problems. Now, I will show you how to fit a power function to the data. The general form of power function is y equal to a into b power x. Here we need not do anything, means like getting normal equations, those things, just we can convert this as a straight line equation. Of course, we know how to fit a straight line to the data. So, our task is just convert this power function into straight line form, means y equal to a plus b x. This is our task. So, just take logarithms on both sides. We can write it as log y equal to log a plus a into b power x, means right hand side is nothing but log a into b equal to log a plus log b. So, this is nothing but log a plus log b power x. Again we can write it as log a plus x log b. So, this is the conversion of y equal to a into b power x using logarithm. So, just take capital Y as log y and capital A as log a and capital B as log b. Then this will become as y equal to a plus x into b or b into x, whatever, both are same. This is like, now this is like a straight line equation. We know how to fit it, because we can write two normal equations and we can substitute the values in that equation. We can get the values of a and b. But thing is, our table will be like this. Previously our table will be x y x square, this is thing, this is the one. But here we need to write the same for capital small x and capital Y, means small x will be as it is, but small y, that will be like this, capital Y. Capital Y means nothing but log y. So, x square, this is x into. So, on solving the normal equations, we can get the values of capital A and capital B. But this is not our task. Our task is fitting a power function to the data, means we need to find the suitable small a and small b values, not these things. What we need to do? We need to convert capital values to small values. As capital A is equal to, log a, we can write small a as 10 power a. In our calculator we have logarithm which is based 10, right. So, we can write it as small a equal to 10 power a and small b as same thing 10 power b. Once we get these values, substitute these values in the general form of power function, then we will get the required power function which will be best fit to the data. So, similarly we can fit an exponential function to the given data. The general form of exponential function is a into e power bx. Again we can convert this as a straight line, because we know how to fit a straight line. But how to convert this as a straight line means doing the same procedure which we already done, means by taking logarithms on both sides, but here we need to take ln, means natural logarithm. The difference between logarithm and natural logarithm is base 10, but this is base e, because here e is appeared, right. Means we can write it as ln y equal to ln a plus ln e power bx, means ln y equal to ln a plus this is nothing but bx, because ln is base e. So, if you take capital Y as ln y and capital A as ln a, we can write this one as y equal to a plus bx, which is of the form straight line. Of course, after this one we can form a table and we can write normal equations and substitute the appropriate values in the normal equations. We will get the values of capital A and small b. Again we need what is our task is? Our task is fitting an exponential function to the data, means we need to find small a and small b, which small a and small b only, not capital A, right. Means we need to convert capital A as small a, because here capital A is nothing but ln A, means small a equal to e power a. These two are available in the scientific calculator, so we can easily done by using scientific calculator. So this is how curve fitting is. So objective of curve fitting is to describe theoretically the experimental data by use with appropriate or suitable function. In this class we have discussed about how to fit a straight line to the data, how to fit a parabola to the data, and how to convert power function and exponential function in the form of straight line, so that we can fit exponential function and power function also to the given data. Okay, as a second topic we have derived normal equations which are useful in fitting a straight line or parabola to the data. In the third topic we have seen two examples, one is related to straight line, another one is related to parabola. All the best to the students. Thank you.